Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean. DigitalOcean's developer cloud makes it simple to launch in the cloud and scale up as you grow. They have an intuitive control panel, predictable pricing, team accounts, worldwide availability with a 99.99 uptime SLA, and 24/7, 365 world-class support to back that up. DigitalOcean makes it easy to deploy, scale, store, secure, and monitor your cloud environments. Head to do.co/changelog to get started with a $100 credit. Again, do.co/changelog.
Let's do it. It's go time.
Welcome to Go Time, a podcast about cloud-native technologies, telemetry, containers, distributed systems, and of course, the people and language that make it all go. You may hear a familiar voice on this episode. Yes, that's Daniel Whitenack from Practical AI. He does sound a bit different than normal. That's because Daniel was on vacation and didn't have his normal recording gear, so he called in from a gaming headset. That's dedication right there. Okay, here we go.
Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking about the new possibilities in AI, artificial intelligence. We're going to dig into that a little, learn about what it means, what it is. And since this is a Go podcast, we're going to keep our eye towards Go on this journey. Joining me today, Jaana B. Dogan. Hello, Jaana. Welcome back.
Hello. Hi.
How are you doing?
Good. What about you?
Yeah, good, thanks. I'm excited because we've got a couple of guests who know a considerable amount of about AI. I'm sure find out. It's Daniel Whitenack. Hello, Daniel.
Hello, great to be here.
Welcome to the show. You are, of course, host of our sister podcast, Practical AI, right?
I am, yes. So, shameless plug for Practical AI if you're interested in those sorts of things. We release a show every week, so check it out.
Yeah, well done. And we're also joined by Miriah Peterson. Hello, Miriah.
Hi.
Welcome to the show. Thanks for joining us.
Anytime.
Yeah, good. Well, we can just kick off if we're ready. I'm interested in just getting a very high-level idea for people that really haven't paid any attention to AI. Who wants to have a go at telling us a little bit about this? What is it?
What do you think, Miriah?
I would say if they want to know, they can listen to Daniel's podcast. I think the way I like to explain it is AI, what we think of AI, is mostly just the typical problem solving we do as software engineers. We just, instead of having to think through it all of ourselves, we're trying to get the computer to think through a little bit of it for us.
I think that's a great starting point. Like when someone thinks about something an AI model does, maybe that's like recognize a cat in a picture, right? So if you think about what that is, like the function that's serving is literally a function, like a software function. You give input data and you get output data, right? So we as software engineers can parameterize functions, right? We say, oh, if I get this query string and it's this time of day, then do this thing or something like that. Yeah. But an AI function or an AI model is essentially the same in the sense that it's a function. It's just that the internals of that function are parameterized not through the developer's logic only, but through a process called training, which is basically like trial and error. So you give the computer a bunch of examples to learn from. It goes through some trial and error process called training to set these parameters of the function. But you end up with just a function written in code, and that's AI, which might be disappointing for some people that think there's some type of, robots always involved or something. But yeah, it's related to robots.
That was a disappointment for me initially, I must admit. And so it's interesting you talk about these functions then. So what does it look like inside it? Because obviously if we write our own functions in Go code, we can see inside that function, we know every step that it's going to go through. Is that the same for machine learning models?
Well, Matt, how would you write a function that recognizes a cat in an image? Let's take an example.
Yeah, if cat.
Yeah, if cat.
Then return true.
So it could be an if statement, right? Like it could be a series of if statements that is like, if I see a bunch of red in the image in this area, then it's a cat, right? That's a perfectly fine model that we could parameterize, but it's not going to be super useful. I don't know that much about cats, but I don't think they're all red. Yeah, so a series of if-then statements like that actually could be considered a type of machine learning or AI called a decision tree. The difference with the AI model would be that the parameters of those if statements, or like the thresholds involved, would be again set through a separate process called training. We wouldn't go in and set them ourselves, but there's kind of innumerable of these structures within the function that can be parameterized. One that people have probably heard a lot about is neural networks, which is kind of just like a bunch of sub-functions in a function that are all tied together in various ways and could have up to like 1 billion parameters or so.
Wow.
You mentioned a couple of times about machine learning. I wonder what is the difference between AI and machine learning nowadays, because when I was a college student, we had a machine learning class, and they were trying to explain us, historically, this area started with AI, but then it became more about machine learning and like pattern recognition. And they were trying to almost distance themselves from AI or that terminology, but now everything seems to be under the AI umbrella again, right?
That's a great question. I'm going to let Miriah take this one because I want to avoid it as much as possible. No, I'm just
Yeah, it's a question that keeps coming up a lot. The easiest way to explain it is AI is a general term for any process that involves some kind of a learned or patterned behavior. Statistical, repeatable processes end up being part of it in just data science. Machine learning ends up being part of it. The deep learning aspect of neural networks are part of it. And then to not confuse it, there's this generalized artificial intelligence, which is the idea that a computer can think like a human. So AI, I think, is more of just the marketable name, any kind of learned or statistical process. And machine learning is kind of what we determine to be the actual computational training or method behind the sellable AI.
That clarifies a lot of things for me. Thanks.
Yeah, that's excellent. That's a tricky question because if you ask it at some AI conference, you'll get as many answers. It's kind of one of those, and various people are opinionated about it in various ways.
So in this problem then of trying to find a cat, you mentioned, you could use if statements and things to go and check pixels, but of course you don't know where the cat's going to be in the image. You don't know, like you said, what kind of cat it is. So you wouldn't be able to write code in the traditional sense. So it makes sense then that we're going to use example data or training data to come up with whatever those internals have to be. Are there any tricks to that? Is it easy? How many examples do we need? And, what sort of challenges are around actually that data?
Yeah, so I kind of like to think about the training process essentially as sort of iterative, almost like iterative testing with table tests of some function, right? So if you're thinking about the trial and error process, right, then you parameterize these bits of the function. And if you're wondering, how good is my parameterization, right? How good did I pick my numbers? Then what you want to do is you want to try some examples and see how many you get right. The difference with sort of traditional software engineering function is that you always expect to get all the examples right. Like you don't, for your API endpoints, you have a bunch of examples in a table. You want to get 100% of those right and fail if you miss one. In the case of the machine learning or AI model, you're going to have a bunch of example images. Some of them are going to have cats. Some of them are not going to have cats. You would never expect to get all of them right, but you want to get as many as possible. So what you do is you choose some random parameters to start with, and then you run your examples through and see how many you got right. Maybe you got like 20% right or something. And then you tweak your parameters a little bit and try again. And maybe you got 25% right. So you're kind of going in the right direction with your parameters. And you kind of just do this iteratively over and over until you get the best parameter set that you can find. And that's how the training process works. Now, there's various mathematics that help in that, in terms of not just randomly choosing parameters, but moving them in the sort of right direction. But it's essentially that trial and error. Now, it depends in terms of the training data and how much you need. It depends on how complicated your model is. So if you have just one if statement, right, then it's going to be fairly quick to parameterize that. And you might not need that many examples. But if you have over 1 billion parameters, like some of these larger models that we see now, you're not going to find all of those parameters with 100 examples, right? You need very, very many examples, which is why with the scale of model complexity that we've seen over recent years, we've seen a similar sort of boom in how much training data is needed. At the same time, we've seen various tricks that allow you to kind of adapt or fine-tune models and not always start from scratch with your training process, which has been one of the reasons why things are moving so quickly, is that there's this kind of idea of piggybacking off of others' works where, Google might have trained on already 200 terabytes of data, and, you're just fine tuning to a particular problem, so you don't need as much.
It's really interesting. One definitions of machine learning back in the day, I had a friend who decided to, define it in a way that if you can't write the function, you just basically brute force it, which kind of really resembles what you're describing. If it's an easy function, you also have an easier option to maybe write it down yourself if it's just one if or whatever. But as soon as it's becoming more complicated, job is actually brute forcing your chances. So the training phase is also getting more complicated.
Yeah, I totally agree with that. One of the things, and Miriah did a great job at describing sort of the umbrella term of AI, but one of the main shifts we've seen in recent years is a shift towards neural networks, which if you think about what's happening there, if you have something like logistic regression, which is based on a kind of simple formula or different regressions, or maybe time series models that have to do something with seasonality and things that have some connection to reality, right? The model is based on some expert knowledge of how reality behaves. Well, that requires expert input into how you form this function, right? Whereas in recent times, the really interesting thing has happened where with these larger neural networks, there's enough complexity in the neural network, there's enough parameters that you could essentially model any sort of relationship between your input and output if you had enough data, right? So now we no longer have to rely on expert input as much in defining the function. We just kind of have a big function and a lot of data, and that allows us to do really interesting things. I'm not a linguist, but I can train a machine translation model, right? And know nothing about the two languages involved. That's pretty extraordinary.
Is this, I think, why they say they don't understand what's going on in that black box anymore? Because it's all magic.
Yes, yeah. It's all, at the end of the day, it's all code, but it isn't very interpretable code, let's say. Yeah.
So you mentioned the recent burst in AI. What's actually driven that? Why are we now seeing and hearing so much about AI? And I ask this with the context that I know that a lot of some of the machine learning research was actually done back in the 50s. And so it's kind of curious. So why now? Why are we seeing it all now?
I think now we just have more data than ever, more everything. They tend to, I'm not a historian, but I feel like somebody with historical knowledge tends to trace this AI boom back to the creation of the internet. All of a sudden you have internet and now everybody's on it and now there's a whole bunch of data. When you have a whole ton of data you can't go through, you try to figure out a way to process all of that data. And we've discovered that these neural networks can process a whole ton of data and can figure out patterns and leverage those patterns for our use or for some kind of output.
Yeah, I think it's kind of multifaceted. I love that word whenever I get to utilize it. I think that, the one thing is the availability of data. The other thing is the availability of compute, right?
Yes, that's the other thing.
Yeah, these models that are processing a lot of data need to, process it quickly and go through many millions of iterations potentially. And so that requires things like GPUs most often. I think then along with that, so it's kind of data, it's compute, but then lastly, it's kind of the realization that so many of these problems that we've been working on for so long, like if you think about like edge detection in images, there were ways to do that before neural networks, right? Or like segmentation in images, or machine translation, or sentiment analysis. All of these things, there were methods for doing it before, but people have started to realize that all of these problems, this logic that we're interested in, can be reformulated in the terms of a generalized machine learning problem, where you have some number of inputs in, a really complicated parameterized thing in the middle, and some number of inputs out. And most problems can be reformulated in that way without making it sort of specialized to any domain. And so now people have kind of just gone crazy with what, neural networks can do anything if anything can be reformulated in this way.
Yeah, that's a really interesting thing. John, on the Slack channel, by the way, we're on Go for Slack for anyone that wants to join the live recordings of Go Time. And you can ask questions like this one from John, he's talking about the training data and the training process. And he asked, how does the model not just only learn what it's seen in the example data? How is it that it can see new data that it's never seen before, a new photograph of a cat, and it knows it's a cat still?
That's a great question that indicates a real problem in these methods, right? So if you had a billion parameter function, right, and 1,000 pictures of cats and non-cats, right, then what's going to happen? Well, you're just going to be able to find the cats and the non-cats in those pictures really, really accurately, almost at 100%, right? But you're not going to be able to generalize, like John mentioned. And this is a problem called overfitting. And this problem has to do with your model being very, very complicated, but there not being enough variability in your data to generalize that model. And there's various ways to deal with this in the training process, including splitting out your data and actually optimizing around data that the model hasn't seen yet, or stopping early if you're overfitting to the data that you're already seeing. There's even recent examples like with OpenAI's work in robotics, where they intentionally put in some sort of randomness into the robotic simulation training data to actually make the model a little bit more robust. You might have seen these really strange pictures of robotic hands manipulating Rubik's cubes, and then a stuffed giraffe comes in and hits the hand. That's their stuffed giraffe perturbation on the experiment, and they were able to handle that situation with the robot because they introduced this sort of randomness into the training process.
Yeah, so it really highlights, I think, the fact that you want your training data to be as close to your real life data as possible. I've done some work in machine learning as well in the past, and what would be very common would be that, say, customers wanted to detect or teach a model that it could learn to recognize logos or something. And the training data was either a transparent PNG or white background, very clear logo. And in the use cases, they're looking for this logo in live video streams, sports feeds, that kind of thing. And it was a kind of difficult challenge there. So would you say that it's important that your training data looks as much like your real world data as possible?
Well, you want your data to be parameterized or directed. I don't know. I can't find the right word for that. But you want your data to be appropriate for the problem you're trying to solve. So if you're trying to we're really liking this cat problem. So if you're trying to get really good at figuring out if something's a cat or not a cat, then having data that has thousands of different kinds of cats and each of them is a cat, and then having data that's not a cat, like having a whole bunch of sharks, would help it determine between the problem of shark and cat. But there's a lot of really interesting techniques that people have discovered to help with that problem just by making different kinds of tweaks to your data. Say you have a whole bunch of different zoo animals and you have discovered that lemurs look really similar to cats, but you want it to still just figure out what a cat is. Well, that's when you start manipulating your data. You can start adding random noise to it, and you can start adjusting size or pixel density. And then your model has to learn to pick out features that are not just maybe placement or not maybe just ear size, but other things. So, and then it doesn't necessarily look like an actual cat anymore because you've added different noises, but it helps to figure out the problem of only finding out what the cat is. So it really depends on what you're trying to look for and solve.
The example that I like to think of with this is if you train the models used in a self-driving car, let's say in like Sweden or somewhere, it's probably going to be pretty good in like snow and maybe like, you know, certain types of environments, right? But if you just say, oh, now we've solved the self-driving car problem, right? And we ship this thing over to Australia, well, the first kangaroo that runs across the road, you're going to like crash your car and there's going to be some catastrophic event, right? So the environment that like your target environment definitely influences how you construct that data to train your models.
It's really interesting because people have been saying that, you know, training is revealing some of the biases in the data that they have never seen before.
Yeah, definitely.
Which makes me also maybe ask more about how do you evaluate the results? We talked about like testing, like, you know, the testing table, and we know like the actual evaluation is more complicated than that, right? Like what goes into evaluation?
Yeah, that's a great question. And the answer is kind of disappointing in that it sort of depends on the problem that you're solving. There's a lot of metrics that are used, though, that are geared towards certain problems. So most of the time, what you do is you say, oh, I'm doing a machine translation problem, or I'm doing an object recognition problem, or I'm doing like a time series forecasting problem. What are the metrics that have been used to evaluate these? So with like object recognition, you might look at something like accuracy or precision or recall. All of these have to do with like false positives and true positives, false negatives and true negatives, and how you balance those. So you might, like in a fraud detection case, you might really want to get all of the true positives, even if you get some false positives mixed in there. But that might not be what you want in another case, right? So your metric is very problem dependent. And in like machine translation, you use this metric called BLEU, spelled BLEU, which has been developed specifically for that problem. Now, that's kind of separate from the bias issues that you talked about. So in addition to like, you could be very accurate, right? But still have bias in your training data, which will create a bias model. This has been shown with like models that model recidivism for offenders coming out of jail, right? And the model will bias against, you know, black males or something like that because of the way that they've set up the data, which is obviously not something that we want to have happening. So there's a lot of people working on this problem. There's great tools from IBM and others that actually allow you to evaluate bias in various categories in your training data, and also integrate that into modifications in your training process such that you necessarily aren't creating these biases, even if it's at the cost of, you know, accuracy or whatever metric you're interested in.
The Practical AI podcast includes insightful interviews with AI experts from Google, the Allen Institute, the Department of Defense, NVIDIA, and more. Hosts Daniel Whitenack and Chris Benson also keep you up to date with news, analysis, and learning resources from around the AI community. They call it Fully Connected, and it is a regular series. Here is a clip from a recent episode.
And maybe, and this is really the first time I have said this ever in our podcast, we will start looking at AI in the future as moving into a post-deep learning world. I tend to, when I'm talking about the present, I tend to tell people I think of AI personally as equivalent to deep learning right now as we're at the beginning of 2020. But I think we may get to the end of this year and that may not be a true statement anymore. And I may have a different answer. So I think that is where we're going. What about you, Daniel? What are some of yours?
This is a quality podcast. Continue listening at changelog.com/practical AI or just search for Practical AI in your favorite podcast app and subscribe today.
So I think that gives us quite an interesting foundation of AI. Maybe we could shift now and talk a little bit about Go's role in this. You know, when we built MachineBox, we had Python for a lot of the internals of these boxes, and we used Go around that to do different things. And that decision really came out because of the maths libraries and some of the other libraries that had already been done. How far are we now in that? What are the options for Go programmers if they want to start to do their own machine learning?
Miriah, what's your opinion? I know you have strong opinions here, so...
I do have strong opinions. Unfortunately, I actually get asked at work all the time if we're going to start doing our machine learning in Go because I talk about Go so much. I think there's a lot here. There's so much at play, but I think as far as how far we are, depends on your problem. If you can use Go and get good result, a good accuracy or good whatever, then you can deploy your model fine. But what I always tell people is, I guess, it's just support. I feel like there's a lot of community support that's lacking in maintaining the packages and the libraries that we have. And so if you do run into an issue, you might not get the response back. And there's a huge support for the Python stuff. And it's just, we got to get people in the community excited about using the Go libraries that are there because they're awesome. They're strong. They just need more support in, we don't want issues breaking production systems.
So why is it so good in Python and not in Go then? Is it just because of the history?
There are tons, PyData, NumPy, or there's a couple other organizations that support the open sourcing of these mathematical libraries and these data science libraries, and they're paying for people to work on them full time. So when you do that, there's just a natural stability that people feel secure about when they're using it. That's not quite there for Go, and I'm not going to ask the Go team to take over our mathematical libraries and the data science stuff. I don't think that's their goal. I think we as a community have a ton of people using Go. I think we have a need to start putting machine learning in our systems that we already have written in Go. And so we just have to start using what's there and supporting the great tools that we have. We have a ton of great tools and libraries. They just need more support and more use.
I always had this impression that there's nothing much out there, so maybe it could be more of a knowledge share problem. Is there like a good way to understand what is the current state of things? Is there like a repository that just captures what is out there?
So there are a few. One of the great resources, if people don't know about it, is there's a data science channel in Gopher Slack, which if you're looking for anything, that's probably the quickest answer that you're going to get because people are very active there.
It's one of the most active channels I'm on.
Yeah, so if I just go over there now, it looks like there's about 1,500 people in that channel, and it's fairly active. There are a few different repositories online. I know I created one at one point under the Gopher Data org on GitHub, although I think it probably needs updating, and I would welcome some PRs there. And there's a few other ones floating around. We'll call out getting involved in the data science channel will help, but also there's a lot of great starting points for experimentation, but also contribution, like Miriah said. So the GoNum family of libraries has a ton of things that are just like numerically related, whether that's matrix manipulation or regressions or statistical tools. All of those things are there, which that is an incredible set of tools that people should know about. That's a great starting point. Other than that, yeah, it depends on what you're looking for. For the neural networks and AI side of things, people might take a look at Gorgania and also Onyx Go, which are two projects that are very active. They're side projects for people. So like Miriah said, contributions are always welcome, but they've come so far in terms of supporting things like deep learning, supporting things like CUDA integrations for GPUs and that sort of thing. So yeah, I would recommend getting involved in the data science channel and those other things. The other thing I'll mention is, as Matt said, Python has its strengths, but Go also has its strengths. So oftentimes where Python people struggle is not in the model training. So they might be able to train a model really quickly and manipulate their data very quickly.
But they can't pass a string in a safe way, can they?
Exactly.
Yeah. So
now when the software engineers come to them and they say, oh, we want to integrate this in our API layer, then all of a sudden there's like a complete breakdown. And so you have this really interesting thing where it's really easy to onboard into Python and do something quickly. It's really hard to productionize that stuff. It's getting a little bit better, but it's generally, there's a lot of blockers there. Whereas if you can wrap things in your Go API and integrate things in that way, that's like there's natural strengths there. There's a lot of great advantages there and a great community around that. So it's kind of, yeah, there is a balance there.
Do you see any rewrites to Go? People might be experimenting with Python, and then maybe if it's possible to achieve the same thing with Go, are they rewriting it when they are productionizing it?
I definitely have seen a lot of people do like training in Python and then inference in Go. That seems to be a fairly common pattern. Like inference, what I mean is like you've trained the model, now you're utilizing it to make predictions. And if you think about what you're doing with that, it's the same thing you would do with like any handler in an API or other application. You're just sending data in, processing it with a thing, and taking data out. And that can be integrated in all the standard ways with how Go operates. So,
does lack of generics in Go create a kind of problem when it comes to implementing these maths libraries and things? Or because I heard someone say that they tried to write something and they ended up using a lot of code gen to get the different types they needed in Go. Is that a problem you've come across?
So personally, I haven't found it to be like the main issue that I'm dealing with. Other people that are developing the libraries themselves, maybe they have other opinions. And I know I've seen also people mention that as well. So I don't know, Miriah, if you have any thoughts there.
I feel pretty similarly. I think that the lack of the generics question is more just people coming from a Pythonic way of doing it and the way that it's worked before, and it just doesn't translate one for one back into Go. So there might be some workaround, but I don't think it's necessarily like a hard block in the way. I think the bigger issue is just the thought. There's just different thought processes, and we have to think without generics for the time being, or sometimes you just got to hack it.
Does concurrency help at all, or is that training process you're bound anyway by other things? Does it matter which order that you do the training in and things?
So generally, if you think in terms of like map and reduce operations, training is one giant big reduce operation where you really need to load a lot of data into memory, at least in batches. So there is like batching that can be done, and you can like separate out the work between workers using some schemes, but it doesn't always result in benefits. It also depends on communication and other things. So generally, like training, I would say is not really the place, but again, with inference and prediction, if you're doing batch inference, like if you want to now tag, 100 million images as either cats or not, right? Then obviously there's going to be huge benefit to doing that operation in parallel in some way. So that's my take anyway.
I'm not going to comment too much. I think concurrency ends up being a bigger beneficial in the actual package development, and I haven't done a whole lot of actual implementation on that side, so I can't really comment effectively.
Fair enough.
Is there any other language features that makes Go a better language for this type of job?
That's a great question. I find that Python, in the sense that like people say it's very readable, but like in the sort of Bill Kennedy way of describing what readability is, would be very not readable, right? So when you're doing this sort of operation and something goes wrong, with Python, the stack traces, like, I've been running some experiments recently, and some of these errors in the stack traces I'm getting out are just like, they're just so hard to deal with because I have no idea what's going on under the hood, or at least where to trace things back to. So I feel like Go's readability, not in the sense of like things being concise, but in the sense of things being clear and logical, I think that like is an extreme benefit to this sort of process where the things that you're wiring up, like these functions, could be very complicated, right? These models. There could be, a lot of integrations that are important, like with CUDA or other things. And so I think that, clarity definitely helps. Obviously, the culture around testing and robustness and integrity is something that I think is a great benefit in Go, which is obviously the place where people hit blockers in terms of Python. On Practical AI, we interviewed a couple of different people around this topic, but Joel Gruss, who works at the Allen AI Institute, they have a package called Allen NLP, which is written in Python, and they really have to do a lot of work to enforce like type labels and utilize CI/CD to do that type checking on all of their code to actually make sure that their code is robust and operating. So it takes a lot of extra work to build that stuff into Python, where for us, it just comes for free. So.
Yeah, sometimes, especially when people are new to Go from other dynamic languages, that's a bit frustrating that it's so strict, but of course that pays dividends very quickly.
Yeah, I just pulled up. There's this other package called Spacey, which is a Python package, and their underlying library that they use for machine learning is called Think, and they just made a big new release of it, and they brand it as a refreshing functional take on deep learning. And one of their first bullet points of why it's so awesome is type checking. Develop faster and catch bugs sooner with sophisticated type checking, and that's something that's like, from the Python perspective, it's like, oh, we can do that. That's like, people are starting to realize that we're moving past this phase of like, let's train models as quick as we can, and into a phase of let's build products and integrate AI into products. And when you start thinking like that, then you have to consider a lot more than just like training things quickly.
So is this technology, obviously it works at big scale. I mean, whenever you see those little boxes that says I'm not a robot that you have to click, sometimes it then says, okay, now just to make sure you're not a robot, just tell me where all the street lamps are in this image, or where the cars are, or which of these images contain cars. And this is basically us all training Google's AI brain, right? So at big scale, when you've got lots of data and all these different users, obviously kind of can make some real use of this technology. But what about small companies? What about people that don't have much data? Should they still pay attention?
Always.
Yeah.
I should say I'm going to throw my company under the bus a little bit. I've been fighting this a lot at work. I'm a huge AI nut. We fight to find a lot of problems where we can use it. We're not super big. We've got about 13,000 customers, about 60 engineers, and we have one model in production, and it does really great sentiment analysis on text replies. If you text your dentist and say, yeah, thumbs up, I'm going to be at that appointment, we know it's a confirmation. Like, it does it great.
What if you say, thumbs up, I can't make it?
Well, usually we get people cussing us out, and that's how we know we texted somebody that's not a customer. But see, it does that kind of a thing, and we started that very early. It was one of the first things we integrated because it was a problem we noticed. We noticed that the text reply C for confirm and N for no was not a good user fit. The more dynamic relationship was a great user fit, and all we needed was our text. That's a really small data set we were able to use. I think we used an open source one, and then we were able to actually create a game for our employees to add more data. So we didn't start with a whole bunch of data, but we've gradually got more, and it fit really well. And it was just a really small use case. So I think there's always a problem. A small company can benefit from using machine learning to really just make their products better.
Great.
Yeah.
I mean, next time try Y and N for yes and no instead of C and N. Just an idea.
C for confirm.
Confirm
C for
or
confirm.
no. Yeah.
And for no.
Yeah, but classically Y and N. But
Yes.
yeah, I see what you mean. Still, that natural conversation's better anyway, though.
Yeah.
Yeah, and I was going to say too, part of what I mentioned around like the rapid growth in AI is due to pre-trained models and transfer learning. So these are two ideas that really benefit people that don't have a lot of data. So pre-trained models basically mean someone else has already trained a model for recognizing cats, which they definitely have many, many times on the internet, right? And so you actually don't even have to go through that training process. You can just pull down a model from the internet and run it in your own code just to do the predictions. There's also tons of APIs where you can integrate this sort of functionality that's AI-driven via API. So whether that's sentiment analysis, like Miriah's talking about, machine translation, object recognition, all of these sorts of functionalities are already available out there. And then transfer learning is basically the idea that someone's already trained a model to do almost what you want. You just have to tweak it a little bit, right? And this is something that I use all the time because I work on a lot of technology for lower resource languages, so natural languages, like languages that people speak. And the languages that we work with, typically, we might have like 30,000 samples of parallel data between like English and this language. If you look at large scale machine translation models, they might have 9 million examples, right? So we have almost no data. And what we do is we really leverage things like, oh, well, there's a lot of data for English, right? And someone's already trained a model for English. Well, if we want to train a model for Singlish, which is a dialect of English spoken in Singapore, then we can start with the English model and then add in our small amount of data to fine-tune the model for the situation we want. And so you no longer have to start from scratch. You're kind of standing on the shoulders of giants in that sense.
I've run into this, just to build off of a lot of what Daniel said. I've had people ask me a lot of times where to get started with AI. And I usually say, find an API that works. Google's got great APIs. Microsoft's got great tools. And while you're using that API, start growing your data so that you can find what you need. So that you have good data. And once you get enough, you can start doing transfer learning and really fine tune your use case. But don't push the problem off. Start with an API and then get ready to make it better.
Hi there, this is John Calhoun, one of your GoTime panelists. When I'm not working on GoTime, I create programming courses that help developers level up their Go skills. And one of my more recent courses, Algorithms with Go, is live, and I wanted to invite you to check it out. So it's completely free, and in it we explore how algorithms and data structures work, as well as how to actually implement them in Go code. So if you've ever had an interest in learning about algorithms or data structures, or if you felt like you understand them conceptually but just couldn't nail down that coding part, this course is going to be great for you. We actually dive into coding everything, we work on practice problems, and it's a lot of fun. You can sign up completely free at algorithmswithgo.com/GoTime. Again, that's algorithmswithgo.com/GoTime. And don't forget that last /GoTime bit. It helps me keep track of how you found out about the course so that GoTime gets credit for referring you. Thanks for listening.
We talked a lot about fine-tuning and tweaking things. Is this like you are tweaking the model primarily, or would you rather try to have a layer on top of that model to maybe eliminate some cases or gather some more information about the incoming data and so on? Maybe pass things to different models and so on. I've seen different approaches when it comes to composing different solutions. What's your opinion on this?
Yeah, it really depends on if you want to do the same task, but for different data, or if you want to do a slightly different task, right? If you want to recognize, I don't know what's close to a cat. Miriah said lemurs are close. I'm not totally sure if that's true.
Squirrels, fuzzy-faced animals, some dogs.
Yeah, you could start like if you wanted to adapt for raccoons, you're doing the same task. You're doing object recognition, and so really, what you want to do is tweak the parameters of the model. You don't necessarily want to change the model structure. Whereas a lot of times in natural language processing or in other areas, there's open language models which will like tokenize your data and create like a learned representation of language, but they won't complete the task that you want. So maybe that's sentiment analysis. In that case, you might have to add layers onto the model for the specific task. And so when people have heard of these things that maybe they've heard of like BERT and Elmo and transformers and GPT-2, and these are all really large scale language models, they really are meant to be fine-tuned to these different tasks and meant to be generalized across them.
A friend of mine, David Hernandez, and I made a face recognition technology once, and the way we did it essentially was using transfer learning. So we took a model that knew about loads of people, specific people, and then stripped away some of the layers so that it didn't quite know all the people, but it knew faces. And then you were able to, just by giving it new examples and not very many new examples, you could then specialize it just for your specific cases. So the net result was you could just train it a small group of faces and it would be able to determine who those people were. So yeah, I think that approach, transfer learning, anything where using other APIs, using other things, I agree with that. I think we should all be hacking a bit more on AI and seeing what it can do in our use cases, because you might be really surprised, hopefully very pleasantly surprised.
Yeah, one project worth mentioning that's very hackable and easy to get into is GoCV. So GoCV has the ability to pull in TensorFlow models for things like object recognition and do things like, face recognition or, finding a certain person in an image and those sorts of things. And really you can do that sort of thing just by pulling in the models, and they have great examples of that. You really don't have to have anything special. They've done a great job at setting that up if you're interested in something that's kind of easy to onboard into.
And Natalie Pistonovich did a good talk about using TensorFlow with Go and essentially using the client libraries there in that way. That is a real option for people. You don't have to be down in the weeds of a machine learning model and all that complexity to be making use of the technology.
Yeah, I feel like I'm often more of people have a vision of AI person as like a really like professor looking person at a chalkboard, like scratching away math problems or something.
But you don't have a chalkboard, do you?
I don't. I would prefer a chalkboard over a whiteboard, but that's a whole nother subject that...
Yeah, that's for next week.
Maybe that's I have to give some unpopular opinion or something in the show, right?
That could be it.
I'm giving mine early, chalkboard over whiteboard. Anyway, I feel often as a practitioner more like a cook than a like professor, where like really I'm just taking someone else's recipe, I'm adding my ingredients in, which is my data, and then I get out something that I can use in my code, right? So I pull a great model from Google or OpenAI or someone, I combine it with my code according to their recipe of how it should be formatted, and then I get out a model that works for me and I integrate it into code. It's much more like that than it is sort of other crazy things that people might have in their mind.
Yeah, I think it's a good lesson. I think it's always worth thinking like that, frankly, because too often we want, for good reason, we want to be able to do all the bits ourselves, and we don't need to, and sometimes it's better not to. Barnaby in the Slack channel was asking about object recognition when we were talking earlier about detecting cats and things. With computer vision, how is it different? How is AI different to that?
Yeah, I think with computer vision, if you think about how this was used, let's take an example of manufacturing and automation, which is something that people think a lot when they think about AI. So cameras have been used in manufacturing for a long time to like detect edges and like insert things into slots and do all sorts of things. But in the sort of computer vision way of thinking, it's almost like one of our guests on Practical AI described it this way. It's like you're finding your way around in the dark. It's like you find this edge and then you move like 2 centimeters this way and then do this operation with your robot and then move 2 centimeters down. It really has no idea what the thing is. It just knows there's an edge here and I'm moving this far, right? Whereas with object recognition or sort of more modern methods, really you are saying like, this is the type A slot where I put in part X, and this is the type B slot where I put in part Y, right? And so it's really recognizing things in the surroundings and performing operations based on that, not just working off of sort of shapes and edges and that sort of thing.
Yeah, and I would also add to that, mash them up if that helps. It helped us in the past. We used a combination of computer vision and machine learning, and the results sometimes were really staggering, actually. So yeah, that's great. Well, I think, Daniel, you jumped the shark a little, but it's time for our regular slot. It's time for Unpopular Opinions. Unpopular opinion.
I actually think you should probably leave.
Unpopular opinion. So, let's see. Daniel, are you going to stick with yours, or have you got another one? Chalkboards over blackboards you prefer?
Well, on my chalkboard, I would probably write something to the effect of AI is the same as machine learning, which is my unpopular opinion that probably I just lost a lot of like practical AI subscribers and followers on all sorts of platforms, but that's my unpopular opinion.
Fair enough. Do you agree with that one, Miriah?
That machine learning is AI?
Yeah.
I use the words interchangeably all the time. That doesn't mean that they always have the same definition. That just means you use the word. They're synonyms. Synonymous words don't have the same definition.
Yeah, good point.
Burn.
That's the best burn, though, isn't it? I like those complex burns that you have to look up later to find out why you're insulted. Do you have an unpopular opinion of your own, Miriah?
I have an opinion. I don't know if it's popular or unpopular.
Let's have it and we'll find out.
But I think it is, generally speaking, unknown. I do a lot of community work, lot, and and as part of that, I go often to speak at boot camps, and I tell them how amazing Go is and how awesome meetups are, and that they should go to all of my meetups and my conferences. But my sales pitch for it is that by going to the meetups, they're contributing to open source the same as a GitHub PR. Like, your community is open source just like GitHub. So I think that everybody that goes to a meetup is contributing to open source, and that's my unpopular opinion.
Ah, that's a great one. That might not be that unpopular.
I know, but it's not verbalized.
No.
It's not formalized, so it is unpopular if it's not formalized.
Okay. That's the second one you got me on. Okay, yeah, no, that's watertight legally, so I can't argue with that one, Miriah. Jaana, have you got an unpopular opinion these days?
In this topic?
Anything?
I'm just too underqualified for this show.
Oh, well, no, not
Me
at all.
Me too, it's okay. I just talk at people a lot, and everybody thinks I know what I'm doing.
You didn't mention your company earlier when you said that. That's it, yeah. You can't point to your hat because it's a podcast. They can only hear us.
I'm going to point to my hat every time I say weave.
You can point to it, but what I'm saying is they won't know that you've done that. Also, that hat looks like it was knitted.
Oh, it's definitely knitted by a machine.
Yeah, AI.
Definitely.
Right.
Robotics.
Yeah, but not woven. That was the thing. So that's the disappointing, but no problem.
What about you, Matt? You've never had an unpopular opinion, have you?
No, they're always popular. I can't help it.
Never mind. I'm not going to be that mean today.
No, you can do it. Go on. You can say it. It'll get cut out, or if it's mean to me.
I was just going to say that you're English, so all of your opinions are unpopular in America. Okay, yeah. That's definitely going to get cut out. Okay, I told you it was kind of mean.
No, not really. Not really. Yeah. I'm just catching up on Slack to see if we've got any other bits and pieces.
So people were mentioning that like the infra around machine learning and AI written in Go. That's probably, I don't know if maybe a good topic to mention here at the end is there's a lot of great infrastructure written for machine learning and AI, and it's written in Go because great infrastructure is written in Go. Things like Pachyderm, Selden, dgraph. I don't know, I'm probably missing some others. Those come to mind immediately. Obviously, a lot of Python people even use Docker and other things. And so I would say if you're wanting to run sort of machine learning AI pipelines at scale, Go is definitely your friend, even if you don't know you're using it.
Yes.
Great.
Anybody that's using Kubernetes is using Go for machine learning. So,
well, we had the CTO of Cloudflare on, and he told us that essentially anybody using the internet is in some way using Go somewhere, So it is kind of cool.
I mean, you're probably using Python as well, right? If that's
maybe
the logic.
Yeah. And definitely JavaScript.
Oh, really? Yeah.
Yeah. And PHP, John said. So. Okay, well, but that is all the time we have for today. So thank you so much to our special guests, Daniel, Miriah, and Jaana. And we'll see you next week on Go Time.
Thanks again for listening. Word of mouth is how we grow the Go Time community. Is there a gopher or aspiring gopher in your life who would benefit from listening? We would truly appreciate a recommendation. Shoot them a quick email or a Slack message, put out a tweet, whatever makes sense. Hey, go crazy, get up from your desk, walk across the room, and tell them in real life. Who knows? Might start a good conversation. This episode was hosted by Matt Ryer and Jaana B. Dogan. Special thanks to our guests, Miriah Peterson and Daniel Whitenack, for dropping knowledge on us. I'm your producer, Jared Santo, and the music is brought to you by the one and only Breakmaster Cylinder. We have awesome sponsors. Please support them. They support us. Thanks again to Fastly, Linode, and Rollbar for helping us do what we love to do. Oh, one more thing. Do you have an unpopular tech opinion that you'd like to share? Tweet it at us at GoTimeFM, and we may read it and respond on a future episode. That's all for now. We'll talk to you next week.
Keep it short and sweet. Then this is where the music plays. This is now the after party. So now you can, Miriah, now you can say whatever you like.
We're still live. We're still live.
Yeah, we're still live.
But I can say whatever I want.
Now you don't have to hold back.
Yeah.
I was joking because you weren't holding back.
Well, then I should tell everybody to go to my conference.
Yeah, well, actually you should anyway. Which is it?
Go west.
Go west. And which direction? How do you get there?
Well, generally speaking, if you fly west, since our world is circular, you'll get there eventually.
So you might as well call it Go East.
You can, if you're in California, east would be the quicker way to travel.
Yeah, but I hope people won't. I hope they will stick to the guidelines set. There's the code of conduct set by the conference. You have to go west to get there. I think that's absolutely fine. When is it and where?
So it's May 8th is the conference day. We have workshops May 7th. The idea is we want to do a regional conference that highlights a lot of the regional talent and still brings in a lot of bigger names to the area. There's a huge Go community here in Utah. I know there's one in Phoenix, Arizona, and in Denver. So we're trying to just, take all of those communities and give them a huge, awesome, amazing conference to celebrate it.
Great. And is the conference in Utah?
It is. I live there. So Sandy, Utah. It's a nice 20-minute drive south of Salt Lake. Quick, little stint over from the airport.
Yeah. And it's a lovely state, isn't it, Utah?
Yeah, and in May, it'll be just gorgeous because it's still green. You'll still have snow on the mountains, but it's warm.
Perfect.
What is the website?
GoWestConf.com.
Okay.
Great. And if the editors are listening, which they're not, they'll put that into the show.
I would be so happy. I would jump.